In today's lesson, we're going to be beginning our look at human population issues. Now, throughout this unit, we'll be trying to establish some of the current trends in global population growth, identify some of the issues that this growth has led to, evaluate some of the reactions to global population growth, and finally, we'll be trying to figure out some solutions to these issues and what this might look like going forward. Now, in this unit, we're going to be doing some data analysis. So a good place to start for us would be look at how human population and population growth in general is measured. And that's exactly what we'll be doing in today's lesson. So we're going to be trying to answer these questions as we move through the lesson today. We're going to start by talking about how the human population growth story has changed throughout our history. We're going to introduce some of the issues that this has presented, as well as what we might do to try to deal with these issues going forward. In short, we're going to be trying to start telling the story of human population growth, something we'll be doing throughout this unit. Second, we'll be answering what is population distribution. Third, we'll be exploring what population density is. And finally, we'll finish by learning how to calculate and estimate a population's doubling time from its growth rate. Now, to start off here, I just want to have a look at this graph here. Now, this graph is showing world population throughout history and how that's changed. And you can see there's a very drastic trend that develops towards the tail end of this graph here. A huge explosion in the world's population starting a couple of hundred years ago. Now, if we look throughout history, going back to when the first humans start to evolve, the world's population was fairly stable, very slow growth rate, generally stable though. And so for thousands of years, it's very slow and steady. In fact, for thousands of years, the global population is hovering just under about 1 billion people, with very little growth. It's very stable during that time. But starting in the 1800s, we start to see an explosion in global population. Exponential growth begins to take place, and we haven't turned back since. Now, one of the things about exponential growth is that you get really big numbers really quickly, as opposed to linear growth. So thinking of counting from 1 to 2 to 3 to 4 to 5 to 6, the numbers get bigger, but it's slow and steady over time. Whereas if you were doubling a number, you go from 1 to 2 to 4 to 8 to 16 to 32 to 64 to 128. The numbers get very big very fast. And that's essentially what's happening here with the world's population. There's nothing left to slow it down. And as the population doubles, it starts doubling more and more rapidly. And just to sort of try to put this into perspective, anthropologists have estimated that throughout human history, so going back millions of years to when the first humans evolved, they estimate that about 100 billion people have lived on Earth. 100 billion unique individuals. There's a little over 7 billion, in fact, close to 7.5 billion people alive today. So what that means is that over 7% of the people who have ever lived are alive today. And that's really hard to imagine. The human lifetime is so short compared to the length of human existence. The average person in the developed world lives to be about 80 years old, and yet people have been around for millions of years, and still over 7% of everyone who's ever lived is alive at this very moment. So this is a rapid expansion in population. More and more people are being born every day, and it's a trend that is not stopping anytime soon. So this presents us with many consequences. Some of those are good, and some of them are bad. So on the downside, you have things like scarcity of resources. People are fighting over the same resources, using the same things, fighting for space. Everyone's looking for somewhere to live. But on the other side, there's many upsides. There's more people to innovate. There's more brain power on the planet. The human brain is perhaps the most complex thing we know of in the universe. So having more people around to think is a good thing. That's more people to solve problems, more people to create artwork, more people to do work. These are more people who are at our disposal to do good things in the world. So it's really it, sometimes population growth gets presented as an inevitable catastrophe that we're just going to keep growing and growing and growing, and there's nothing we can do to stop this. And this is, the downfall of human civilization, uh, the Malthusian catastrophe, which we will discuss in more detail later on. But it's not inevitable. It's how we deal with these problems as a species that will determine the outcome. And again, we're going to be looking at what some of those solutions might look like. And so to take a bit of a closer look at that point at which human population starts to explode, this graph here is zooming in on the period from 1800 to the present. And what each of these red dots is showing is a billion more people on Earth. So here in 1800, we're at around 1 billion people. And then for each of these dots here, this is 2 billion people. And around 1930, 1940, a couple of decades later, we get to 3 billion. A couple of decades later to 4 billion. A little bit later, 5 billion, 6 billion. And then in 2011, we reached 7 billion people. And within 10 years, it's estimated that we'll reach 8 billion. The current world population is approximately 7.5 billion people as of 2016. Now, why does this start to happen? Well, there's a few things that start to happen around the turn of the 19th century that really set the groundwork for this explosion in population. So this is the time when the Industrial Revolution starts to take off in the Western world. And there are many factors at play here, things which allow population growth to take hold. There's new technologies which are coming about. There's medicine, advances in medicine, so people are living longer. More children are surviving through childhood. Fewer women are dying in labor. There's better sanitation, so not as many people are dying of disease. There's better education. So all these things play a factor and allow the world population to start booming. And it's uncertain what the future holds for us as a species. So there are different scenarios in terms of growth based on different estimations, and all these estimations here make different assumptions about what population growth is going to look like in the future. So we could continue having this exponential trend with very high population growth, and you can see here, if we continue at this rate, we'll be into the, over 10 billion people by the end of the century. We could have a more slow growth, medium growth, which will still lead to more people on Earth, but at a slower rate. And then finally, we might plateau, reach a stable point where the population kind of stops growing. And most experts estimate that would probably happen between about 9 and 12 billion people. Now, which path we take depends on many factors, and each feature has its own unique advantages and disadvantages. But before we can start looking at the long-term impacts of population growth, we need to do some groundwork to understand the data we're going to be looking at. And so the first term that we need to understand is something called population distribution. Now, population distribution is a pattern of where people live. It's a qualitative term, which means it's descriptive. It's describing the qualities of a population. And it's useful for describing how a population is distributed throughout a space. And we could describe places as being either sparsely populated, those areas that contain few people, or densely populated, those areas that contain many people. And so for an example, we could look at Canada's population distribution. So this map here is showing how Canada's population is distributed. About 35, 36 million people live in Canada, but we're not spread out evenly. There's many areas in Canada where very few people live. And we can see here there's a very high concentration in the population along the Canada-US border. In fact, about 75% of Canadians live within 160 kilometers of the US border. And this has a big impact on Canada. And there are both human factors that lead to this concentration, so things such as trade, as well as physical factors, so things like climate. It's harder to live in the Arctic because you can't really grow stuff there, and it's cold most of the year. Whereas a region like the GTA, we have more temperate climate. It's warm in the summer. The winters are cold, but they're bearable. You can grow things. It's easier to support a large population. On the other hand, we could look at population density. Now, this is a measurement of the number of people in a given area. And this is a quantitative term. It's dealing with numbers. It's dealing with quantities. And it's calculated by dividing the number of people by an area of land. And it's expressed as a number of people per square kilometer. And you would calculate population density following this very simple formula here. So it's simply the number of people divided by the area of land, and that gives us our population density. And again, that would be expressed in the unit people per square kilometer. And so here's what population density looks like on a global scale. So this map here is showing the darker areas, which have higher population density, as opposed to the lighter areas, which have lower population density. So darker areas, there's more people living per square kilometer. Lighter areas, there's fewer people living per square kilometer. Now, even with an exploding population, one thing that should stand out to you here is that still the vast majority of the Earth's land masses are not densely populated. It's not space that's a limiting factor in terms of the Earth's growing population. There's lots of space for people to live in. So even in these areas where there's dense populations, even they're not like people are crowded and can't move around. Think of a city, a place. In Canada we have cities, we have places where people live. Think of an area like Toronto or Vancouver or Montreal. There's many people in those areas living, many more people living per square kilometer than in the vast majority of Canada. There's still lots of sparse population throughout the world. So the areas around the world with the highest population densities, so we could look at areas like South Asia, particularly India and parts of China. We could look at a place like Japan, which is very highly densely populated, as well as Western Europe. Whereas again, North America, relatively sparsely populated compared to those areas. Now, population density can be affected by both physical and human geographic factors. So this first slide here, we'll look at the physical factors that can affect population density. So firstly, things like landforms. So low lands, which are flat, tend to support higher population densities. So for example, the Ganges Valley in India, which has one of the highest population densities in the world. On the other hand, highland, mountainous areas tend to support fewer people. So think, for example, the Himalayan mountains. There aren't many people living at the top of Mount Everest. Natural resources also play a factor. So areas which are rich in resources, so things such as coal, oil, lumber, fish, etc., they are going to support a higher population. So think Western Europe. And then on the other hand, places with few resources aren't going to support as many people. They'll have a lower density. More temperate climates, so places that they aren't too hot, they're not too cold, they get some rain but not too much so that it's always flooding. Those areas tend to support a high population density. So a really good example of that would be the United Kingdom, a relatively small island but with a population of about 100 million people. It has all these factors working in its favor. And on the other hand, places that have temperature extremes, climate extremes, places that are extremely hot or extremely cold will have lower densities. So think the Sahara Desert in Africa or the Canadian Arctic. There are some people living there, but not nearly as many per square kilometer as the rest of those continents. And then, on the other hand, we could look at human factors, human geographic factors, which can affect population density. So there's political factors. So places that have stable governments tend to support higher population densities. So think of a country like Singapore or Japan. highly concentrated populations, highly dense populations. They have nice, strong, stable governments, and have for many decades. On the other hand, places that have unstable governments, there's lots of political unrest, perhaps there's a civil war going on, they're going to have much lower population densities. So think of a place like Afghanistan or perhaps Syria today. There are social factors which affect population density. So some groups might want to live close to each other for security. So think of the US and people wanting to live in cities. On the other hand, there might be a cultural bias against living near people. So some cultures might prefer isolation. And this is something we find in some Scandinavian countries. And finally, there are economic factors which affect population density. So places with stable economies, plenty of job opportunities, quality social services, a social safety net, high levels of urbanization, they're going to have high population densities. Whereas on the other hand, if you have limited job opportunities, there aren't many people living there, they're going to have a low density. So think like the Amazon rainforest. And finally, the last statistic that we want to look at here is doubling time. Now we can estimate how long it will take for a population to double as long as we have its population growth rate. And we do this using something called the rule of 70. Now this is an estimate that assumes the growth rate will remain at its current level, which of course is not always the case, but this is an estimate. It's meant to give us a rough idea of how long it will take this population to double, again, given that current growth rate. And the way we do this is we calculate by dividing 70 by the growth rate as a percentage. So for example, if we were to take a growth rate of 3.5%, let's assume we have this population, it's growing at 3.5% every year. The doubling time for this population, we figure it out, we take the number 70, we divide it by 3.5, and that equals 20 years. It would take 20 years at a 3.5% growth rate for this population to double. Now this makes sense. If we had a 0% growth rate, for example, we would take 70 and divide it by 0 and we would get, well, it doesn't make sense. It would take an infinite amount of time for a population with no growth rate to double, which makes sense. If we had a negative number, so let's say this is negative 3.5%, the population shrinking every year, it's going to tell us how long it would take for that population to have given that current growth rate, that negative growth rate. So in this case, if this was a growth rate of negative 3.5%, the population was shrinking by that amount every year, it would take 20 years for that population to have itself. So in summary, although the global population was fairly stable for thousands of years, population has grown exponentially since 1800. Population distribution is the pattern of where people live. Population density is the measurement of how many people live in a given place. Population density is influenced by both physical and human geographic factors, and we can calculate how long it will take for a population to double given its current growth rate by using the rule of 70.